So last time we were not here, we were nearly here. We were down here. We talked about comments, right? And we had a comment if your line of code, like your code is supposed to be descriptive. So the point of a comment is to make your code more descriptive. But but do not comment every line of code. Like if you've got a line of code that says like s equals s plus 1, and you have a comment next to it saying, well, this takes the value of s, adds 1 to it, and reassigns it to the variable s, I'm going to laugh at you. And it won't be a good laugh, it'll be a bad laugh. I'll be annoyed. I'll be like, oh. Like, no, that's not necessary. Don't over-comment your code. Only comment things that need commenting. If your code is descriptive enough, I don't need a comment. A code is meant to describe something that isn't going to be clear. Like, here is an example. Perhaps it's a bit of a contrived example because this code probably becomes a lot clearer, not needing a comment, if I just had a better variable name. If the variable on line 2 was like Euclidean distance, then that line of code becomes a lot more obvious. Now, a lot of people in here will look at that code and recognize it as like, oh, that's Euclidean distance. No big deal, right? But, we've been talking about Euclidean distance just recently. It was one of the activities above. And maybe you weren't thinking too hard about the code, and you look at that and you're like, what the hell is that, right? I realize a lot of people in here look at that and go like, yeah, it's Euclidean distance. It's the sum of the square of the differences of the points, right? Like you recognize it. But let's be honest. Looking at it, imagine there's no variable there, no d. You just look at that statement, that expression, and you go, oof, what's it doing? And you might say, well, you could have better variable names. But those variable names, x1, y1, x2, y2, they're actually pretty good in the context of what this is. Maybe you could call it like x coordinate 1, but now that's kind of annoying. So this might be a situation where, okay, look, most people might recognize this, but you could also agree that that looks kind of like a hairy line of code. That comment, now there's no ambiguity. What does it do? Oh, it does what it literally says right there. Calculates the Euclidean distance between 2 points. Oh, yeah, of course, that's what it does. So a comment is used to describe code. Python doesn't care about the comments. It ignores them entirely. They're for a human. You don't need to be thinking you need to comment every line of code. Comment your code if it needs commenting. Someone asked in the other section, will I lose mark if it's not commented well? And I'm like, well, no. You don't lose marks because it's not commented well. You'll lose marks because your code isn't descriptive. And comments will help make your code descriptive. If you don't need a comment because the code is descriptive enough, then you don't need it. If it's confusing, any concern of understanding, yeah, add a comment. But this is different when it comes to doc strings. It's a fancy way of saying a comment for a function. Every function, I don't care how dumb it is, you add a doc string to. Actually, let's hit pause on docstring and let me show you one more thing about comments. So if I go here, this is a comment, here's another comment. These are single line comments, and then you could have multiple line comments by creating a block where you have 3 quotes. Then you can have whatever you want. I don't need to start each line with a hash or anything. This is all comments, and then I close it. Okay? So that's like a multi-line comment. I run this. Python just ignores all those things. So a doc string is one of those. But it's at the very beginning of all of your functions, right after the def line, but before any of the actual code. The doc string 1, describes what it does, 2, describes the parameters, and 3, describes what it returns. This is a good example. You might say, well, Celsius to Fahrenheit should be descriptive enough. Fine, maybe. Still write your doc string. And one of the reasons we write doc strings is there's software, there's a program. In fact, it's like the same program that I use to generate these websites. You use that to Python math. See this website here and how like each function has a little description? This web page was generated from those doc strings from code. This website, there was a program that looked at the code, it took the name of the function and all the doc strings and created this website for you. So we write doc strings because it self-documents then. So converted temperature, what does this function do? Well, it says right there, converted temperature from Celsius units to Fahrenheit units. Okay, cool. It takes 2 parameters. Wait, no, it doesn't. It takes 1 parameter. We list the params, and this syntax is very important. If you get the syntax wrong, Python will still work just fine because it's a comment. But the doc string for the documentation generation wouldn't. So we follow this convention, this format, this syntax, colon, param, name of the parameter, colon, describe what it is. If I had 10 parameters in this function, I would have 10 lines, each with param, param1, param, param2, param, param3, and so on, whatever they're called. And describe each one. And then finally, you add, well, what is it actually returning? And now, you know absolutely everything about that function. Hooray. So when I was saying you don't need to worry about commenting things if it's self-descriptive enough, except your functions. You always write your doc strings for your functions. Always, 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 always. What is this? Oh, is this one of those jokes? Yeah, it's a joke in programming. Always comment your code, otherwise you forget. Yeah, I don't know. The internet's full of these stupid programming memes, right? That one's not even that good. I've seen way worse, but funnier ones. And when the time comes, I want you to remember I warned you. What's this one? Yeah, I don't know. Anyways. Any questions? I warned you. Write them. Write those doc strings. Yeah? Cool. Okay, now, propositional logic. Right now, I'm about to give you a lecture on something you already know very well. Nothing is going to blow your mind here. All of these ideas you're familiar with. But you probably haven't talked about these ideas as formally or as deconstructed as I'm about to. First and foremost, there's a new type we're about to talk about called a Boolean. I've mentioned this before in several contexts, you may remember. And the new type Boolean is interesting because an integer can have value 1, 2, 3, 4, 5, negative 42, 175. There's a lot of integer values, right? There'd be like an infinite number of them, barring what the computer can actually encode. Same with, floats, strings, any combination of strings. But Booleans are different in that they actually can only ever take on one of 2 values. Instead of an infinite number of possible integers, asterisk, computer representing those integers, Booleans only have 2 values. It could either be true or false. If you have a Boolean variable, its value is either true, false, one of those. A lot of this is going to be stuff you're already aware of. So not only are you aware of these Booleans, but you're also aware of operations on Booleans. Boolean operators. You're familiar with arithmetic operators, right? 1 plus 1. Plus, it means add. You're already familiar with Boolean operators. So unlike plus, the plus operator, it takes 2 integers, it adds them together and gives you back an integer, right? Boolean operators will take 2 Booleans and give you back a Boolean. So first and foremost, let me ask you a question. I'm putting you all on the spot. Here's a big test, and I want you all to answer. Am I wearing shoes? Very good that you said true. If you said yes, I'd make you leave. Am I wearing a hat? Very good. And no one said no. Good. From now on, it's always true and false, okay? Am I wearing shoes and a hat? Am I wearing a red shirt or a green shirt? Look at it, you're already experts. You know everything about this. This is basic propositional logic. I'm using or and and. Now here's a curveball. Am I not wearing a hat? You look at that. I even tried to trip you up, but you knew it. Smell like burning rubber in here to anybody? Yeah? True. Ah, there you go. That's weird, right? Is anyone trying to burn anything? All right, hopefully that passes. Now, one thing I want to emphasize is when I said the statement, when we use those Boolean operators, whether you liked it or not, you all did this in your head, but you probably skipped steps. You probably didn't even think about it. But the reality is, when you're using that and or that or, in your brain, you are evaluating each statement first to get to its value, whether each statement was true or false. And then you applied the and or. Let me put it this way. Let me be clear what I mean by that. When I asked you, is my shirt red or green? Wait, I am wearing a red shirt or a green shirt. And you said, true. But that or wasn't working on the statements themselves. It wasn't working on, he's wearing a red shirt, he is wearing a green shirt. No. It was working on what those statements evaluated to. So let's be clear of the steps here. These Boolean operators don't work on general statements like that. They work on Boolean values. So when I say, am I wearing a red shirt or a green shirt? First, you have to ask the question, am I wearing a red shirt? Then you ask the question, am I wearing a green shirt? And then you said, okay, true or false. Well, all that mattered was one is true, right? So let me say, am I wearing shirt and pants? True, right? Am I wearing a shirt? Am I wearing pants? True and true is true. I know in your brains you looked at both and was like, yeah, you calculated the answer to am I wearing a shirt and pants as one, but really we have to break these things down into their values, each statement's final value, before the operator is applied. Let me put it this way. Based on what you know there, if something is true, and another thing is true, and I say true and true, what is the result? What about true and false? What's the result? What about false and true? What about a false statement and a false statement? False, yeah. It's the value of the statements. I know it feels weird when I'm just saying true and true. You're like, well, that's just true. But it really is about what those statements evaluate to. Like, am I wearing a hat and am I wearing shoes? Well, that's false. Why? Well, am I wearing a hat? That's false. Am I wearing shoes? That's true. But false and true is false. So it's not the, am I wearing a hat and am I wearing shoes? It's, am I wearing a hat? That's false. Am I wearing shoes? That's true. False and true? That's false. Is it clear that I'm breaking those steps down? That's important to emphasize here. Also, I will say, right now I'm talking about or. There's and, there's or, and there's not. Not's interesting because it actually only works on one value. Am I not wearing a hat? I didn't have to ask two things. So what's not true? And what's not false? Of course. I'll show you the truth table here real quick. This is a fancy truth table. This is just how we could describe the possible combinations. I mean, with Booleans, we know each Boolean can have one of two values. And if I'm using a Boolean operator, like a binary Boolean operator that takes two values, I can calculate every possible answer. So I've got, what happens if I have so right here, what I have, this is called the truth table. I have a column that's A and a column that's B. And with the A and B, I've generated every combination of trues and false. I've got true, 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 false, false, true, false, false. Okay? then I say, well, A and B. Well, if I have something true and I end it with something true, I get back true. True and false is false. False and true is false. False and false is also false. So true is only true if both the operands are ultimately true. Or, on the other hand, it's always true unless both values are false. This is perhaps an overkill formalization of what you're already aware of, but yeah. And then here I'm doing it on not A. It's only working on A, so not true is false, not true is false, not false is true, not false is true. So that's the truth table. Now I will warn you, English is funny because or can be ambiguous in the English language because, I was telling the lecture this morning, the section this morning, I couldn't remember it and I should have looked it up, but whatever. There is a word for this ambiguity in English. I can't remember what it's called, but or can be ambiguous. To be very clear, in programming, or is always true unless they're both false. True or true is true. True or false is true. False or true is true. False or false is false. But we have another one called exclusive or. That, it's used, but we don't use it that often. But when it comes up, it's neat, it's cool, you use it. I didn't even mention it here. But exclusive or is a little different. It's or, except the result's true only when it's one or the other. True or false, false or true. Those are true. But if you have things where both statements are true, it's actually false with exclusive or. Because like in English, if I ask you, and maybe you don't even find it that weird, but some people might, if I ask you like, am I wearing a shirt or pants? Right? Does that sound kind of like a weird statement? Because you're like, well, you're wearing both. It's not one or the other, right? Because English is kind of ambiguous like that. Or like, do you mean like the exclusive one? Or do you mean, right? I can't tell. So, long story short, to eliminate the ambiguity, programmers have very clear separate operators for when you want or, and then there's exclusive or. But you don't use exclusive or nearly as often as you use regular old or. So just be clear about that. And the reason I'm emphasizing the whole thing about like, these operators are working on the ultimate values of the statements, like the true or the false property of the statement. Because on tests, I will often ask like, okay, if I have a statement that, like if I say true and false or true, and I ask you, what's the answer? Half the people in the room go like, that doesn't make any sense. You have to like ask a question. That's not a question. It's like, well, no, it is. These are operating on the base true or false things. Where if I asked them a question like, is it sunny outside and raining or not raining, right? Like, then it would be easier for them. Whatever. Just remember, it's always about what the final value of each individual statement comes down to. Am I wearing a hat? And am I wearing shoes? That's false, not because you looked, it's false because you went, am I wearing a hat? That's false. Am I wearing shoes? That's true. Therefore, false and true is false. Those steps are important. What was I going to say? Let me ask you something. Here's a quick little thing. If I say, am I wearing a hat? And do I even need to ask you another question for you to know the answer? No. Because both things must be true to get true, otherwise it's false. If the first thing I look at is false, there's no need, I don't even care what the second question is. It's false. It's kind of like a you see a giant long-ass mathematical expression multiplied by 0 at the end. Oh, it's just 0. Right? You can immediately know by looking at one thing. And similarly with or. If the first thing am I wearing shoes or, I don't need to ask the second half of that question. You already know the answer is true because, well, I am wearing shoes. Now, if I ask, am I wearing a hat or, well, you don't know yet because, well, it depends on if the other statement is true or false. So it's kind of a neat little thing to know about. Okay. Is the sky blue and is water wet? Well, that's true. Not because and didn't work on those operators, or and didn't work on those statements. It worked on, is the sky blue? That's true. Is water wet? True. True and true. That's true, right? Is the sky blue and is it over 100 degrees Celsius outside? Well, that's false. Is the sky blue or is it over 100 degrees Celsius outside? True. Is it not over 100 degrees Celsius outside? True. We can play this forever. You're already experts at this. You know what this is. Okay, for or, both statements, yeah, that was just the warning. There we go. Cool. Boolean types. Booleans are a type in Python like integers, strings, and floats. Type true, we'll say Boolean. Be careful. Let me just show you. It breaks. And I just said if you ask the type of true, it'll say Boolean or bool. What did I do wrong though? It's got to be uppercase T. It even changed its color to blue. In other programming languages though, it'll be the opposite. So you just have to be aware which language you're in. Unlike integers, yeah, they can only take one of two values, true, false. Boolean operators, well, we just looked at 3. The first 2 are binary operators, meaning they work on 2 values and give you back a value. Not is a unary operator. It works on 1 value and gives you back 1 value. True and false gives you back 1 Boolean, false. Not, it only works on 1 value. Not true, well, that's false. Just like mathematical operators, except where arithmetic ones, a Boolean arithmetic operator like addition takes 2 integers, if we're dealing with integers, and gives you back an integer. These Boolean operators take 2 Booleans give you back a Boolean. That's all. Nothing crazy. It follows all the same rules that you're used to, just in a new way. But we also have comparison operators. So, true and false is not overly helpful, especially because that's like if I wrote the line of code, print 1 plus 1. And you're like, well, why would you even write 1 plus 1? Why wouldn't you just write 2? It's always going to be 2. What's the point? It's the same deal here, right? True and false. Why write that? That always evaluates to false. What's the point? Well, we got to remember, we're going to use these things with variables that are storing values and whatnot. With situations, like, for example, it's not 100, okay, we need a way to check the temperature, okay. Based on how we use this type of logic in our everyday lives, whether you like it or not, we need a way to evaluate statements into their Boolean values. So, for example, is it not over 100 degrees outside? Well, when I ask if it's not over 100 degrees outside, you need to actually check, right? You need to check, well, what is the temperature outside? And you need to check if it's greater than 100 degrees, right? So we need a way to compare. And fortunately, you've seen this before. I was watching a show with my kid, who's 3, and he already got this one figured out. So if you don't, you should feel really bad about yourself. Remember learning in like element when you were like this big, the greater than and less than signs? And you never really used them after like grade 2 when you learned about them the first time, right? Remember that? Inequalities? Well, they're coming back. They're finally useful. Isn't that great? And when you learned it, did you learn about it like, oh, it's the alligator trying to eat the bigger number? Remember that? Yeah. That's the show. It was a space thing trying to eat bigger numbers that were asteroids. I don't know. It's what it was, but same thing. This is another operator, but it's a comparison operator. And what's neat about this Boolean operator, this one here, that's a greater than, What's neat about this one is it takes two, like in this case, it takes two integers, but it gives you back a Boolean. Where the other ones took two Booleans, gave you a Boolean, or two numbers and gave you a number, this one takes two numbers and gives you a Boolean, which is neat. It's just different. So if I ask you, is 1 greater than 7? Well, that's false. There's a bunch of comparison operators. If you want to check if things are equal, we can't use the regular old equal sign because that's already used for assignment, right? A equals 5, well, that assigns the value 5 to the variable A. But if you want to check if things are actually equal, well, we do equal equal. We write two equals to check if they are in fact equivalent. If you want to know if something is not equal, you do exclamation point equal. Or you can do equal equal and then not it, but whatever. Greater than or equal to, less than or equal to. And be aware of the greater than or equal to, right? Because if I ask you, is 5 greater than 5? What's the answer? False. 5 is not bigger than 5. Is 5 greater than or equal to 5? True. This would be an example of like an edge case, and we deal with these edge cases with greater than equal, right? Where it's kind of like, well, it's on the line. Which side does it go? Well, we have to just be aware of that, right? So if I ask you, is it over 100 degrees outside? It's not, thank God. And it is exactly 100 degrees outside. Is it over 100 degrees outside? No, because it's equal to 100 degrees. It is 100 degrees outside. So here we go. Take a moment, just hack away with some of these Boolean operators, these comparison operators equal. Try to write crazy statements, I don't know, see what happens. And yeah, just be aware of equals equals. All right, I put a couple examples of doing the last thing, doing things of different types. And there I'm comparing an integer to a float, but it's saying it's true. I'm comparing a integer to that float, but it's false because obviously it's not the same. And lastly, I'm comparing an integer to a string, and it's false. But notice it didn't break. It didn't crash saying not defined for integer and string. No, it operated. It just told you, no, it's not the same thing. They are not equal. Now, mind you, if I were to do this, I wonder what's going to happen. Oops. Yeah, now it's going to say, well, I mean, what does that mean? Is 1 less than the string 1? Well, no. So you still have to be mindful about what the hell you're actually asking Python to do. Now, here's a funny thing. Are these numbers the same? They shouldn't be. Well, Python thinks they are. This is clearly just a situation of floating point precision and it just not caring anymore after a certain amount. This just goes back to that whole spiel I went on about watch out for floating point numbers. They can be weird if you ever want to compare them. So just be aware of that. Even funnily enough, even if you do like, are you less than? And you run it, it says false. Even though like, well, no, 1 clearly is less than that. It's a little bit more. No, it doesn't even care anymore. There will be a point where it does care. Clearly you can see there. Huh. That's fun. Oh, wait, it's not the same. There. There we go. At first I thought that's weird because it was the same number of decimals, but then I realized this actually was one more space over because there was 2 equals. Anyways, doesn't matter. You can compose, okay, we've seen different operators that work on different types. And as long as the types check out and we follow the order of operations, which there is one, it's going to follow what you're used to, what you learn. Remember like BEDMAs, right? Brackets, exponents. There is an order of operations you can go look at. It's got a lot more different types of operators. The last operator that I'll actually run is an assignment one, which is kind of neat. So if you have a big, long expression, the last thing that will actually happen based on the order of operations is actually do the assignment, which makes sense, right? Do all the calculations. Once you're done, put the value in the variable. Actually assign it. But there are a bunch right here, all these different operators. The math will come before not and whatnot. Let me show you what I mean. Let's validate that. Is 1 plus 1 greater than 1? Is 1 plus 2 greater than 2? If the order of operations was do the comparison first versus this one, clearly it's doing the addition first. When in doubt, for yourself or for another programmer to make it more clear, you can add your parentheses just to make it more explicit, just so no confusion happens. So here, if we were to do all this, well, what do these evaluate to? Okay, well here, look, we could cheat. On the first one, I've got an or there, and on the right-hand side I see is 17 not equal to 18. True. I don't even care what's on the left side anymore, right? If I have something that's true or something else, it's true. Is 19 less than 18 or is 17 not equal to 18? What's that? Is that true or false, that whole statement? True. But remember, the or is not operating on those whole statements. It's operating after things were evaluated. First it goes, is 17 not equal to 18? Or actually, no, let's say first it goes, is 19 less than 18? So the left-hand side becomes false, it's evaluated to false. The right-hand side is 17 not equal to 18? Come on, wake up. Wake up. You aren't waking up. So we have to evaluate these things first. False or 17 not equal to 18? True. False or true? True. 100 equals 100, or sorry, 101 equals 100, and 66 minus 17 is less than 54. False. How did you know so fast? The first one, right? I don't care what's on the right-hand side. 101 does not equal 100. That's false. False and anything is false. Good trick. We could keep doing this forever. Yeah, there we go. I think we've done enough for now. Yeah. Here's a warning. I just showed you some rather, like these are getting kind of crazy. I mean, the ones with an explicit Boolean value in there are kind of useless because you wouldn't really use those in practice. But if you had a line of code that looked like this, don't. You can. There's nothing stopping you. That's too much. There's too much going on there. That's too complicated. You got to figure out how to simplify it. Break it down into smaller steps. I don't know. It's too complex for me. Any questions about that? You clapping for me? Thank you. Okay, now, testing your code and type hints. Obviously, you've all been testing your code. Every time you write a function, you test it, right? And if you haven't, you should feel really bad about yourself. So we need to test our code. And right now, all the testing we've done has been very like, okay, write the function, run it a couple times. Did it work out the way I wanted it to? Yeah, great. But the problem with that is, well, it's prone to like you rushing, not being that rigorous. How much thought did you really put into each like little test you did? And what happens if you change your code after a little bit? Did you retest it? There's some gaps that can arise. So we like to be a little bit more rigorous in our testing. The rule is, like I realize on your assignments, you're going to do your assignment, you're going to give it to me, the TA is going to mark it, and tells you if you're right or wrong. But in practice, as you go up in higher years, or if you get a job as a software engineer, it's your job to prove to me, to demonstrate to me that your code is correct before I'll even give you the time of day to look at it. That's how it's going to work. And so we have systematic ways of rigorously testing all of our code. So yeah, once you write a function, you want to ensure that it's actually correct. And once a function's written, we want to call it a few times to check that it's working, but we want to be a little more systematic and thorough with our testing. And we end up writing small snippets of code specifically designated. Its only purpose is to test itself. The code is written to test other chunks of your code. It doesn't have any other functional purpose other than ensuring correctness, which is a good thing because it's not about writing code, it's about writing correct code. And in addition to being for correctness, writing tests also really helps think about what our code is supposed to be doing. If I told you, write a function to convert Celsius to Fahrenheit, you could come up with a bunch of test cases before even writing that, right? You don't need to know what that code even looks like to write tests for a function that converts Celsius to Fahrenheit. I know that 0 should be 0. Negative 40 should be negative 40. I know 10 should be, I think, 50, right? So I can actually, I'm aware of what, if this is the input for this function, I know what the output should be, even before I write the code. So when you write tests, it can be really good about, it really gives you a chance to be a little bit more thorough and thoughtful and deliberate with your code. And it makes you think about, well, what's correct, what's not correct? And are there any funny little special cases where something might go wrong? Edge cases. Edge cases like I talked about, that greater than or equal to, right? If you've got some code and for some reason some critical value is like 56, it's good to test, okay, a value around maybe 54, 55, 56. That's around the edge of that like line, and make sure it's all giving you the right values around that edge and whatnot. Now writing tests. Typically, if we're writing tests, there is a more correct way to do it than what I'm about to show you. But the more correct way, we are going to learn near the end of the semester. I can't start teaching you that right now because you just don't know enough about all these other little things in order for it to make sense. So we'll get there, but that's not to say that the tests that we're writing are insufficient. The tests that we're writing, they're going to do the trick. They're just a lot simpler to do it the way I'm about to show you. We're just going to use the special keyword in Python called assert. The program will crash if the assertion fails. Which is a good thing because that means your code's wrong. All right, here's a very simple example. It's going to be a contrived example for now, but bear with me. I want to write the absolute value function. You remember absolute value? What's the absolute value of 17? What's the absolute value of negative 17? Exactly. It's just if it's positive, you leave it alone. If it's negative, ditch the negative, right? That's what it is. This function already exists in Python, by the way, right? Print abs of 11 gives me 11. Negative 11 gives me 11, right? It already exists, but let's pretend it doesn't. I don't know. If a function was given to you by Python, you don't need to worry about testing it. You could be pretty confident it's going to work correctly. But we're going to use this as an example to show you how testing would work. So there's really not much to test with the absolute value. We should test, okay, here would be a case. If I gave the absolute value a positive integer, it should give me back a positive integer. If I give it a negative integer, it should give me back a positive integer. And 0 is a funny one, because it's neither. If I give it 0, it should just give me back 0, right? But we would call maybe 0 the edge case in this scenario. So here would be a way to write tests for the absolute value function. It is entirely unnecessary to test it because we're going to assume it's correct because Python gave it to us. But this would be how I would write tests for the function absolute value. I hit run, and it produced no output. That's good. All right? When I hit run, I don't see anything. But let's say I made a typo in my test. So this would be an example of my test being wrong, not the function being wrong. But let's see what would happen if it failed on one of them. It would crash, and it would say that that one failed. It even tells you which case failed. But it'll break after the first one. So if you have multiple ones that fail, it'll only tell you the first one that failed. Just be aware of that. But seeing nothing, well, that's a good thing. That means nothing went wrong. But let's say, for example, we have this version of broken absolute value. We look at this code, we know it's broken. It just simply returns X. And I've got a comment there saying this one's going to fail. I know it's going to fail because I've designed it to fail. If it worked correctly, if I wrote the absolute value function and it worked correctly, I'm ignoring the function itself. I know what it's supposed to do. If it worked correctly, 5 should give me 5. I should get 5 if I call it with negative 5. And I should get 0 if I call it with 0. And by the way, the order in which I do it, it doesn't matter if I do the function call on the left-hand side of the equals or the right-hand side. But let's say I wrote this function, I thought it was correct, and I'm just going to make sure that the tests are going to pass, because obviously I'm good at writing oh no. And it tells me what went wrong. So the tests inform where the bugs are. All right, we'll follow up here Friday. And as always, if you're lost, confused, have questions or anything, you want to come say hi, come to office hours.